Hi guys, in this lesson we will look at negative and complementary angles, and be aware we always work in radians nowadays. IB trigonometry, radians. So what about these negative angles? Well, first of all, this is the unit circle. Let's assume this is a unit circle, and let's put in an angle there of theta. First of all, you should know that the number here on the horizontal axis represents the cosine of theta, and the number here on the vertical axis for that point represents the sine of theta. In other words, this point P here has coordinates cosine theta, sine theta. Those are the coordinates of the point P on the unit circle. So the coordinates depend on the angle. Now what if we make that angle negative? What happens to cosine and sine? Well, let's have a look. Here's that positive angle theta, and if I take the same angle theta but in negative, oops, a bit more, there, and this is still theta, but it's negative theta, and this angle is positive theta. Now, because the angles are the same size, the number here on the horizontal axis will be the same number, and that number is the cosine of theta. So that means for a positive theta, the cosine of theta, or for a negative theta, the answer is the same. So the cosine of positive theta is the same as the cosine of a negative theta. This is called an even function. That's for later. If the cosine of theta equals the cosine of negative theta, or if the function value for x is the same as the function value for a negative x, then we call it an even function. For the sine, let's have a look. So here we go, there's theta. Here's negative theta. Now the sine is that value there. But for the negative angle, the value is here. The sine of negative theta. But this number here is the same number on the y-axis as the number here, only this one is negative. You see, the origin is here, this is a positive number, there's a negative number, but it's the same otherwise. So from this we can conclude that the sine of negative theta is just the same number as the sine of positive theta, but with a negative in front of it. So the sine of negative theta is negative the sine of theta. That's what we call an odd function. The tangent is also an odd function, so I'll give you, without drawing, that the tangent of negative theta is negative tan of theta. So these are the negative angles, and we have three new formulas there that we can use relating to odd and even functions. Now let's look at the complementary angles. Complementary means they add up to 90 degrees, and 90 degrees in radians is of course pi over 2. Thank you very much. pi over 2. Angles that add up to pi over 2. So let's have a look what happens when I have an angle here, which is theta, and I take this theta away from pi over 2. So I take this distance away there, I get this angle. So the green angle is pi over 2 take away theta. Let's try that again. Pi over 2 take away theta. So the blue angle is theta, the green angle is pi over 2 take away theta. Now it might be a bit tricky to see, but the number here on the horizontal axis, which is the cosine of theta, turns out to be the same as the number on the vertical axis for pi over 2 take theta. And vice versa, or analogous, the vertical displacement there, so the sine of theta, turns out to be the same as the cosine of pi over 2 take theta. Now this is not a proof, it's just me showing it, and as you can see it's a bit of a mess there, but let's just write it up. So I'm saying that the cosine of theta is the same as the sine of pi over 2 take away theta. Now that's convenient, that's handy, because now you can convert from cosine to sine really quickly just by changing the angle a little bit. Vice versa, as we said, the sine of theta is the cosine of pi over 2 take theta. So here we have another two valuable formulae that we can use in our work.